Hey, I'm Elliot. I build stuff, and this is day 2 in the series of having a look at Advent of Code 2023 and how I tackled the problems. As I mentioned in the last video, I happen to do it in Rust. This isn't a Rust programming video per se, but we might talk about some of the Rust particulars along the way. But last time we covered day 1, I should say, and now we'll get stuck in day 2. So, jumping right into it, again, not really covering the story too much, but the challenge from day 2 was to read in these lines here, each of which was the steps in a game. And in this game, the person draws some colored cubes from a bag and notes how many of that given color are drawn out. And within the game, they draw a number of times, each separated by a semicolon, and that's the game. Not a very exciting game, but a game nonetheless. And part 1 of the problem is to say, look, we only have 12 red cubes, 13 green cubes, and 14 blue cubes. Of the listed games that were played, how many of those are actually possible? So, for example, if we have 13 green cubes and then we draw 20 green cubes, we know that that game is impossible. Cool, game 3. So yeah, the example here, game 3, there's 20 red cubes drawn in that hand, and we know that there's only 12. The goal here is to find all of the possible games, sum the IDs of those games, so in this case game 1, 2, 3, 4, 5, those are the IDs, and report the answer. And spoilers, the answer was 2268. So, coming across to how this was implemented. Now, this code contains both part 1 and part 2, but we'll just talk about the part 1 stuff for the time being. As per last time, we read in the file and put its contents into a string. This time we make use of a data structure called a hash map. So for those unfamiliar, a hash map is a way to take a key. In this case, it's the words red, green, and blue, and pair that key with a value. In this case, it was 12, 13, and 14. Now, this particular hash map represents the maximum number of balls that they told us were in the game. Now, the reason I picked this, we could have easily stored 12, 13, and 14 as an array of values. But I picked a hash map here because if we go back to take a look at the game files themselves, or the input file, I should say, we can see here that the structure of the file was a number followed by the words blue, green, or red, and then that's repeated a number of times. Now, to make lookups and parsing easier here, I decided to make use of a hash map so that we could grab the string directly from the input file and look up the maximum value quite quickly. And this is what a hash map is really good at doing. So we loop through the lines. If the line happened to be empty, we just quit. The reason for this was, depending on whether I copied and pasted the input files from the website or saved them as a text file, sometimes I'd get an extra empty line at the end, and rather than normalize all my input files, I just decided to just break if there was an empty line. Anyway, what we did here is then we took the input, which as a reminder was game, and then the number, and then a colon, and then a number, and then red, blue, green, or whatever it was, and then a semicolon to represent the end of that particular draw. So first we split by a colon and a space to get the game X part of this input. Then we know that there's only going to be one of those. So within this challenge and within most of the days, I kind of assumed that the input was pretty well sanitized already. If you're building this in a production system, you'd probably want to do a bit more input validation than I've done here. But this part here first just grabs the first part in the iterator, which in this case is the word game, a space, and the letter X. I then replace game space with nothing and then parse the result into a 32-bit integer. We make use of a library here in Rust to just provide some additional context in the case that there is an error, so that when it crashes, it prints something more useful to the screen, and it means there's a lot less unwraps and result unwraps than there would otherwise be. But we won't go into that too much. The point here is to just grab that number for the string, which is the ID of the game. Then we take the second half of that original split, so X blue, Y red, semicolon, and however many games there are, and that becomes last. We store a Boolean value which is called game OK, which indicates whether or not the game that we are currently checking would have been possible given the maximum ball count that we listed above in that hash map. Game max we'll talk about in a little bit. That's related to part 2. Then we take the hand. We take that last value, that second half. We split it by semicolons so that we can get each of the individual draws. We then split that portion by commas because the values, X blue and Y red are separated by a comma and a space. And then we split that resulting bit. So in this case, let's do a bit of an example here to make this clear. If we have X red, Y blue, semicolon, Z green. Once we get into this next section, the first time we come through, we'll have X red, Y blue. And then once we get into this section, we'll be working with X red. And then the second time through this loop, we'll have Y blue. Second time through this loop, we'll have Z green. And in this case, there's only this one draw in this example. So then working with X red, we split it based on a space character. We grab the first part of that, which in this case is X, but it's a number. And we parse it into a 32-bit integer. We then take the second portion and we use that as a color. And then we look up the maximum number of balls that is allowed for that color in this max balls hash map that we talked about earlier, based on the portion of that string color. Now, again, as I said earlier, I did not much to sanitize user inputs in this one, but in a production system, you certainly would. You could have colors that didn't exist in your hash map and you'd want to handle all of that in a more robust way. But again, given this was a challenge, the input was fairly well structured and well formed. I didn't go down that path here. We won't worry about comp game or ball count at the minute. But for part 1, we then compare the number of balls to the maximum allowed balls, which is this comparator here for that given color. And if we find a case where we have more balls than we were allowed, we mark the game as not okay. And then, ignoring this part as well, because that's part 2, which we'll get to, if we loop through all of the hands in that particular game, we then check if the game was okay. So if it made it to the end without violating any of the rules, we then add its ID to the total and print the total at the end. There's probably a shortcut here that I'm just noticing now, in that if we mark a game as false, there's not really any need to keep checking the rest of the hand. So that could have sped this up a little bit. The input on this one was not huge, so not a big deal, but a little optimization there that we could have jumped into. So that's part 1. Now coming back over here to the rest of the question, part 2 makes a slightly different set of rules here. Now what they're saying is, instead of saying that we have a limit of 12 red cubes, 13 green cubes, and 14 blue cubes, we instead, game by game, work out the minimum number of each color we would need for that game to be valid. So to take this first example, we got 3 blue, 4 red, 1 red, 2 green, 6 blue, 2 green. Based on that, then we need 4 red cubes, 2 green cubes, and 6 blue cubes to make every one of those draws possible. So the update for part 2 is to run through this process, work out the minimum number of each color that we need to make the game valid, and then we multiply those numbers together. So for the first one, it's 4 times 2 times 6, and that is the power, as they call it, for that particular game. And then we sum all of those powers. Now you'll notice there's a lot in Advent of Code. Multiplying those 3 numbers together and then summing them doesn't really mean anything, but it is a way to get you to do something complex, take the answers and combine it into a single number that you can then put into their system to check against. This simplifies against things like needing to check the output of every single game, and you'll see it a lot in these sort of programming challenges. So the answer for this one was 63542. Spoilers there if you haven't done the puzzle already, but let's jump back in and have a look at how that worked. So this is the same code as before, but we'll talk about the part 2 components for the time being. We'll jump back up to the top of the file. We store a variable here to store the total power. That power, as I mentioned before, was those 3 numbers multiplied together. Then the first place down here that we note a difference for part 2 is this game max hash map. So this is a mutable hash map, which means it's something we're going to change as we iterate through. And it stores initial values for the maximum number of red, green, and blue cubes that you would need to satisfy this game. We initialize it to 0, and then as we loop through, we get to a point here where we say, look, based on the color that we're up to, so again here, X red, we say, all right, based on the game thus far, or the number of hands that we've been through thus far, what's the maximum value that we've seen for the color red? And if the current number of balls, so in this case X, was greater than the maximum we'd seen so far, so let's say it's the first one through and that's 0, then we replace within the hash map the current value of the ball count for that given color. Now we do that across the entire hand. We would, if we had put our shortcut in here to break and stop checking, incorrectly do that, because if we are doing part 2, we do need to loop through all of the hands regardless of whether we've found a mismatch, which is possibly why I took that out, thinking back to it. But anyway, we get through the game and then we calculate the power. So we start a value at 1, we loop through the values in that hash map, so that's just the 3 values for the balls, and we multiply them together to get the power of this particular game. We then add that to the power total, and then we report that at the end. So that is part 2 of day 2 for Advent of Code 2023. Hopefully you found this one interesting. Once again, this one was pretty straightforward, given that it was pretty early in the piece. As we start to go through some of the later days, you'll see the complexity build up. But really, I don't think there was anything here that was too crazy or too unfamiliar to most. I think probably the programming principle that is most of note in this one is the hash map. And hopefully you saw how we made use of those here. And if not, something to look into whenever you have to match a key, so in this case a string for the color, to some sort of value. It's a quick way to look something up. So with that, let's wrap this video up. If you found this interesting, found this useful, please do consider subscribing. If you have any questions, put them in the comments. Happy to answer them. And otherwise, I will catch you at the next one. Bye.